Hi students, today we are going to discuss the three questions.
So here what you want to know is that the first question. A stone is dropped from a top of a tower of height h. First sub question, state work energy theorem. Second sub question, prove law of conservation of energy in this case. And the third sub question, draw variation of potential energy and kinetic energy with height of the stone. So these are the three questions. So these questions can come under essay type models. That means 5 marks questions. So first we are going directly to the first question, that is first one, that is state work energy theorem. State work energy theorem. You all know that work and energy both have same unit, that is joules, right? Same as a unit, that is joules. So it doesn't mean that both are same. They are same in a way, but there is a small difference. Actually, work energy theorem states that particular difference. And what does this work energy theorem states? It states that the work done on a system is equal to change in its kinetic energy. In the case of potential energy also, gravitational potential energy also, it is same. That is, the work done on a system under gravitation will be equal to change in its gravitational potential energy. So here, more precisely, you want to state either one of the statement, that is, work energy theorem states that the work done on a system is equal to change in its kinetic energy. This sign, that is, this sign means delta, which denotes change in kinetic energy. So work done on a system is equal to change in its kinetic energy. So this is a work energy theorem. It can be also, once again I am saying, it can be also practical or applied for gravitational potential energy also, that is, work is equal to change in gravitational potential energy. But for the exam, for this questions, you write W is equal to delta kinetic energy. So this is the first question. Second one, prove law of conservation of energy in this case. Just imagine that a ball is here. A ball is here. This ball is dropped from this particular height to here. Just imagine after some time the ball has reached here. Okay. So now in this scenario, you want to find out the energy is conserved there. Here two types of energies are coming. They are kinetic energy and potential energy. Kinetic energy and potential energy. You want to state that at each point, I am taking 3 points, that is A, B, and here it is C. And just imagine that the height from this highest point to point B is X. The total height is equal to H. So this height will become what? Total minus X, that is H minus X. Okay. Now this is a scenario. And you want to prove the energy. It is said energy only. Here what they meant by energy is a total energy. So total energy will be equal at point A and at point B and at point C. So you want to take each point wise, that is at A. First case at point A. Total energy is equal to kinetic energy plus potential energy. Just see that the ball is at stationary position from the beginning, initial point, that is point A. So kinetic energy is equal, you all know that half mv square plus potential energy mgh. Here any movement is there? No, there is no movement is there. So that means there the kinetic energy will become 0. That is only at point A the potential energy is there, that is mgh. So the total energy will be equal to mgh. Now just see at point B. What is the case? Here also energy is equal to kinetic energy plus potential energy. Kinetic energy is equal to half mv square plus potential energy mgh. You all know that. But here the problem comes there. The ball has first here, it came here, came here, came here, came here, and it reaches point B. Now the issue is that you want to assign the value of V and H here. You cannot take directly this equation half mv square plus half plus mg h. So what is the change here? You have to see. You all know that kinetic energy is equal to half mv square, right? Okay, half mv square. But and potential energy is equal to mg h. Here what is h? Is it the total height, or the ball has reached right now here, right, at point B? That means now the potential energy should be calculated for this height from the ground. This height is what? H minus x. H minus x. Now one more thing is there, V square. More precisely, I want to just simplify this equation. V square is equal to, you all know that U square plus 2AS, or simply V square is equal to U square plus 2gs. S is the displacement. So S is the displacement. So what is the displacement here? The ball the ball has started from A and reaches point B. That means the displacement is x. Displacement is x. So here one more thing is that what is the initial velocity? It is nothing but it is 0. So V square will be equal to 2gx. So let this be equation 1, let this be equation 2. So from there you will get energy is equal to what? Half m instead of V square. Instead of V square it will be 2gx plus mg. I'm just opening the bracket mgh minus mgx. So here 2 cancel. That is mgx plus mgh minus mgx. Mgx minus mgx cancel, and you are getting last point, that is mgh. Now at point C. At point C. Here also the same condition, that is total energy is equal to kinetic energy plus potential energy, that is half m v square plus the ball has reached here. That means from here it starts from point B and it reaches here. That means there is no height. If there is no height, your potential energy will become 0. That means potential energy will become 0. So what is remaining there? Half mv square. So here also v square is equal to u square plus 2gs. Here also u will become 0, and what is remaining? V square is equal to 2gs. Displacement, it starts from point A and reaches point C. So displacement is what? The total height, that is equal to h. Substitute this value. Let this be equation 3. This equation 4. 4 in 3. So by substituting you will get energy is equal to half m v square. Instead of v square it is 2gh, that is equal to mgh. That means here you can see that in the first case you are getting mgh, and the second case also you are getting mgh, third case also you are getting mgh. That means all the three conditions, if the ball is thrown from a particular height or dropped from a particular height, you can see that if I am taking 3 points, at 3 points I am getting the same total energy, and the total energy is equal to the sum total of kinetic energy and potential energy. So this is the case. This is how you prove that yes, the energy is conserved in the above case. Now the third sub question, that is draw the variation of potential energy and kinetic energy with height. So you are going to just draw the variation of potential energy and kinetic energy with height. Means you are plotting a graph. Okay, that is energy, and this is height. This is the case there, right? Now you know that if a ball is dropped from a particular height, at the maximum height, it will have maximum potential energy. Okay, just see that this have a maximum potential energy there, and this potential energy will decrease, right? With time, the potential, and with the height, the potential energy decrease. It means on increasing in the height, your potential energy will decrease. That means you are just decreasing there. And you can see in the case of a kinetic energy, at a maximum height, your kinetic energy is 0 or less, minimum, and on increasing the height, you will get a maximum kinetic energy. So here this graph will denote your kinetic energy, and this one will denote, that means the downward line will denote your potential energy, maximum potential energy to minimum potential energy. Whereas in the case of kinetic energy, from minimum kinetic energy to maximum kinetic energy. Here you can see that at each point, the sum total will be equal to same. They will be same throughout, without any doubt, because they are conserved. So this is a third case. Now the second question, moment of inertia of a body is measure of its rotational inertia. First sub question, what are the factors on which the moment of inertia of a rigid body depends? Okay, we have to find out the factors on which the moment of inertia on a rigid body depends. So what are the different factors? The first factor that should come in your mind is mass of the body. More precisely, the distribution of mass of the body about the axis of rotation. That means if I have a rigid body and it is rotating along a axis, if I'm taking, this body contains different types of small particles. It's a constitution of small particles, and each particle have different mass, m1, m2, m3, m4, like that it goes on up to mn, for n particles. So here the mass distribution is a very important thing. That is the distribution of mass of the body about the axis of rotation, about the axis, this axis of rotation, about this axis only the body is rotating. The body is rotating either in clockwise or in anti-clockwise direction. So the distribution of mass of the body about the axis of rotation is another factor. The next one is that the distance of the body from the axis of rotation. That means if I want to just find out the moment of inertia of this particular particle, then this distance, that is distance from the axis of rotation, is plays an important role. That means now the third factor is that the orientation and the position of axis of rotation with respect to the body. That means how you place the axis so that the body will rotate. This is another factor. That means in some regular bodies, some axis will be along or perpendicular to the plane through z axis, or sometimes the body will be having an axis diametrically. Sometimes it will have an axis parallel to the diameter. So these depends, and for all these cases your moment of inertia will change. That means the orientation and position of axis of rotation with respect to body is an important factor. Next one, shape of the body. It depends upon shape of the body. If you are taking a ring, you will have different moment of inertia. If you're taking a disc, you will have different moment of inertia. If you're taking a irregular body, you will have different moment of inertia. That means shape of the body is also another factor. So distribution of mass of the body about the axis of rotation, the distance of the body from the axis of rotation, the orientation and position of the axis, rotation with respect to the body, and the fourth one is shape of the body. These are the various factors which affects the moment of inertia of a rigid body. Now, the second sub question, state the theorem that helps to find out the moment of inertia of a disk about any diameter. So you have to find out the moment of inertia of any regular body about diameter. That means if I have a body like this, if I have a body like this as in the diagram, I want to find out the moment of inertia along this particular axis. Now the body can rotate in this way, and I want to find out the moment of inertia along this axis. So how can I find out this thing? So in the case of a body, it will have, I'm just saying, z axis, x axis, y axis, right? X axis, y axis, and z axis. So here, how can you find out? The question is, how can you find out the moment of inertia of a disk about any diameter? So it can be found out by using perpendicular axis theorem. Perpendicular axis theorem. So what does this perpendicular axis theorem states? According to the perpendicular axis theorem, the moment of inertia of a body about an axis perpendicular to the plane of a body is a sum of moment of inertia of the body about any two mutually perpendicular axes both lying in the same plane. That means if I have z axis, x axis and y axis, then if I want to find out the moment of inertia along any axis iz, that will be equal to what? Ix, this moment of inertia along x axis plus moment of inertia along y axis. So this is now the third sub question, that is, a disk and a ring of same outer radii have the same mass, which will have a larger moment of inertia about an axis through the center and perpendicular to the plane. So you have a ring in your hand. You have a ring in your hand and you have a axis here, and also you have a disk. You have a disk there. Okay. And you want to find out which one will have more moment of inertia. In the case of a ring, the moment of inertia is given by m r square, mass of the ring into r square. The case of a disk, you will get the moment of inertia along this particular axis, the axis which is given in the figure. That means perpendicular to the plane, and it is moving through the center. So half m r square. And here it is clearly given that same outer radii and have same mass, because here mass both are same, and radius both are same, so that you'll get for the ring mr square, and for disk it is half mr square. So you know that here which one will have more moment of inertia from the equation, that is, moment of inertia of a ring will be greater than moment of inertia of disk. So this is the thing. So I hope that you understood this one. Now moving to the third question. A cyclist speeding at 18 kilometers per hour, that is, velocity is equal to 18 kilometers per hour, on a level road takes a sharp turn without reducing the speed. The radius of the circular path is 3 meters. The radius is equal to 3 meters. First one, centripetal force provided by dash. Second one, derive an expression for the safe speed of the cyclist at the turning. And the third sub question, if the coefficient of friction between the tire and road is 0.10, will the cyclist slip while taking the turn? So these are the things. The first sub question, that means if you have a circular turn, a cyclist is here, and he is moving like that. That means here this distance is 3 meter, radius is 3 meter. And here one more thing you want to keep in your mind, that is V is given in kilometers per hour, that is 18 kilometers per hour, which will be equal to 18 into 5 by 18. You all know this thing. This will change conversion there, that is 18 cancel, that is 5 meter per second. So you want to change that thing into meter per seconds, but because your radius is given in meters, so 5 meters per meter per second. So this is the velocity there. Now here the first question, that is a centripetal. As it is moving in a circular path, obviously a centripetal force is there. And you know that in the case of a tire, if you have, okay, just imagine that you have a cycle here. Okay, and the cycle is like this. Okay, now you are just taking a turn in this road. So obviously there's a static friction. There is a static friction at this particular point of contact. And while turning, this static friction is acting this side. Yes. Just imagine you just ride a cycle and you're clicking a photo of that cycle. So at that particular moment, there is a frictional force acting between the tire and the road. And you can see that, just imagine, you want to imagine all these things. You can see that the frictional force, and that is a static friction there. The static friction will be acting towards the center of the circle, and Fs, and this Fs will provide you what? The static friction will provide you what? Centripetal force. This will provide you the centripetal force. Okay, so your first answer, that is a static friction. Next, the second question, derive an expression for save speed of the cyclist and the turning there. You're going to derive the expression. Yes, you have a road here and you have a cyclist here. Okay, you have a cyclist and you have a man. Okay, you have a cyclist here. So here the weight of the body is acting in which direction? mg. Your normal reaction is acting in which direction? This way. And your frictional force or static friction is acting in this direction, Fs. So these are the various things from the diagram. Now from the diagram itself, your normal reaction will be equal to what? Will be equal to your mg. That means both will be same, right? Because it's a straight road, it is a level road, so there is no need of taking the components and all. There is no need. So n will be equal to mg. You know that both are opposite, so they balance each other. N is equal to mg. And you know that this particular thing, that is F, the frictional force is given by mu n, or some textbook instead of n it is written as r also. That is normal reaction. We only want to know that n or r is equal to the normal reaction. Fs is equal to mu n there, that is mu times, mu is what? Coefficient of static friction. Mu is equal to coefficient of static friction. So mu n there, but you know that n is equal to what? It is equal to mg. So you can write Fs is equal to mu mg. Now you know one more thing, the previous case, that is a centripetal force mv square by r, where r is acting in which direction? This is a centripetal force. I'm just writing F centripetal, Fc, mv square by r, which is given by mu mg. From there, m m cancel, and this r will go up, and the remaining will get v square is equal to mu r g. From there, more precisely, v is equal to root mu r g. Beyond this particular velocity, you will slip from the track. You will just go out of the track. Now the third sub question, C. If the coefficient of friction between the tire and the road is, that is mu is equal to 0.10, will the cyclist slip while taking the turn? So this is the question there. Okay. So you know from the previous equation, v is equal to, it is root mu r g, and you just substitute the value. It's equal to 0.10 into r is equal to, the radius is given as what, 3, right? So 3 into g, 9.8 is equal to 9.8, or simply I can write it is 10. For my convenience, I am just writing it as 10. So okay, it is equal to 10. So you will get what? 10, that is equal to root 3. So root 3 is equal to what? It is approximately 1.73 meter per second. You will have 9.8 as an acceleration due to gravity, but here I am using 10, and I got the point that is I got the answer that is 1.73 meter per second there, right? So here, at what speed the cyclist is moving? He is moving the actual speed. V actual is equal to what? 5 meter per second, but actually he should move only at 1.73 meter per second. Besides, above that, he will slip away from the road. So here in this case, V actual is greater than V. That means the V at which he should move. That means he will slip. He will slip.
So that's it. So just go through the 3 questions and just go through each one by one. Thank you.